should have the CLA banner over there. This is a celebrity life activity. These free and fun events that are available to you, provided by Celebrity. What a wonderful thing they do. And this series is called Beyond the Podium because that's where I am. I'm beyond the podium, and that's where we should be. And that's the intention of Celebrity. So we interact with you and provide you information in an interesting and, I hope, enjoyable way. So we are going to talk this afternoon about the Pacific Ocean. It's very appropriate considering we are in the Pacific Ocean and will be for the remainder of the voyage as we go back to Vancouver. I say back to because that's where we're getting off, and we will go home, having been on this ship since the 2nd of March. This is me. I'm retired. I've asked the previous audience how many of you were retired, and I sympathized with those of you that weren't. My field of science is something known as health physics. It's my experience that when I ask the audience, nobody knows what it is unless they worked in the field. So let's test it out. Does anybody know what health physics is? Do I see any hands going up? I don't see anything because I'm blinded by the light. Does anybody know what health physics is except my wife? Who knows? No, none of you. See, told you. Yes, it is a small sample. It is basically radiation protection. I worked for the federal government of Canada for most of my career doing radiation protection, and I have published over 200 papers in the peer-reviewed literature, creating new knowledge. And that's enough about me. Probably cover some other bullets in some of the other talks. I always like to start off with something humorous at the beginning of my talks, and this one I think is very appropriate for all of you that are going to fly. Enough said, right? Who likes flying? I don't see any hands going up. Oh, there's one or two of you. You like flying? You go business class, do you? Oh, not cattle class like us. I hate flying. Anyway, first of all, let us talk about the size of the Pacific Ocean, because it is remarkable, actually. Here is the Earth, and the water from the Earth has been removed. This is the diameter of the Earth in kilometers and miles. Now, let us look at the water that we have removed from planet Earth. And here it is. There's all the salt water. And this is the diameter of all the salt water. It looks pretty insignificant, doesn't it? Even though we know it covers most of the planet. That's because it's not very deep. Now, the other thing that's really kind of surprising and a little bit off topic, but it's in the vein of water, is here's the fresh water, that little dot there. You probably heard that in the future we're going to have water problems. That's one of the reasons. We don't have much of it. Water is only 0.05% of the Earth's mass. So despite the fact when you're up there in the buffet looking out at that endless amount of water in the Pacific, it isn't. We have a small amount of water, relatively speaking. That being said, it's pretty big on the surface. Big. It goes from the north to the south, from the Arctic to the Antarctic, and it goes from Asia to the Americas, pretty much across the face of the planet. And in fact, if we took all those continents, we could drop them in the Pacific. They would fit in the Pacific. Maybe that's a comment on how little land we have. This is what it looks like. So here's all the continents in the Pacific. Obviously now we've got a big ocean going around the planet because we've moved them. But anyway, there are all of them. So here's some statistics. This is the surface area. So it's 1/3 of the Earth's surface. And as you can see, north to south and east to west, those are the dimensions of the Pacific, covering 1/3 of the face of the planet. Looks like half there, but it's only 1/3. Now, just in case you think it's big, I want to put things in perspective for you. So over on the left, we have planet Earth. And over on the right, we have planet Neptune. Yes, and Neptune is a gas giant, but I also included it there for comparison. In the middle is an exoplanet. This is a planet going around another star about 45 light years away. It is the star Gliese 1214, and that's B, that's the planet. We believe it's mostly water. That planet is mostly water. It's 6.5 times the mass of Earth, mostly water. Pacific's not looking so big now, is it? So all things are relative. Anyway, back to Earth. There's Pacific. This is the surface area, and this is how it stacks up with the other oceans on our planet. The smallest one being the Arctic down the bottom there, the Arctic, the Southern, the Indian, the Atlantic, and then the Pacific. And you can read those numbers for yourself. Let me display those in a slightly different way. Let's normalize it to the Arctic. So basically I'm dividing by the Arctic surface area. And so this is how they stack up. There's the small one, and there's the Pacific. And as you can see, it's almost twice the size of the Atlantic. Big. If we add in the volume now, so we're going to put the depth in here. So we look at the volume. This is how the volumes stack up relative to the Arctic. And as you can see by that increase in height there, obviously there's some really deep areas in the Pacific because the volume is that much greater. In fact, there's enough water in the Pacific to build a bridge to the sun that has a 1 square kilometer base 4 times over. That's 150 million kilometers 4 times over. There's enough water to do that. That's a lot of water. That being said, I also told you there isn't much water. It's all relative. It depends on how we take our reference point. But that's a long way. There's a lot of water there to be able to do that. This is the equator, and there is a current that goes from east to west. It was discovered in 1952 by the man whose name was given to that current. It's a subsurface current. It's called the Cromwell current. And as you can see, it is long, and it is the longest current in this area, flowing always east to west in the Pacific. Also at the equator, interestingly, the sun will be directly overhead. Just a little sidebar, twice, which is at the equinoxes, and this is what it looks like. Anybody been on the equator, on the equinox? On the equinox? No, I see you've been on the equator. We've been on the equator too, but not on the equinox. Where did the name come from? Mar Pacifico is the origin of the Pacific's name, and that translates into peaceful sea. Is it peaceful? Let me show you some photographs that were taken from a ship that had a rough time. This is the MS Stolt Surf. This was taken in 1977, and as you can see, it's having a rough time. Excuse the pun. Here it is again. Look at the height of this wave. This is being taken from the bridge. So that wave is almost up to the bridge. You better hope our captain knows where to go, right? This was in the chief engineer's office from the water that got into the ship. It wasn't sinking. This is just the water that got in because it kept crashing over the deck through the rough weather. And this was the damage that was done on the deck by the water hitting the superstructure as that ship was going from where it was going to where it was going. And it couldn't avoid the storm, unfortunately. You probably have seen some videos of cruise ships that get caught in bad weather. Have you seen them? Yeah? So it can be pretty bad. So it's not the peaceful sea. How many ships have sunk in the Pacific? Anyone? We'll take a hazard a guess. 5,000. I heard 5,000. 10 million. I heard 10 million. Gosh, I don't know if we've ever built 10 million ships in the history of the Earth, but that was a very good guess. The answer is, in fact, unknown. World War II, there is an estimate around about 3,700. So who said 5,000? You weren't too far off. And that was just World War II, so who knows before that. And unfortunately, we can't sort of go down to the bottom and count them because these things actually decay with time in salt water and will be obliterated as time goes on. What about wind and wave in the Pacific? And I'm sure some of you recognize this. This is the area we're in where that was drawn, a very famous sketch. So this is the Earth, and of course in the north, the Earth are going clockwise in this direction, and they're going anti-clockwise in the South Pacific, and of course on the equator we've got the doldrums. Those trade winds were very important at ships like this, and this is a recreation of the Golden Hind, which was Sir Francis Drake's ship, and it followed his route in the recreation of that. Those trade winds were very important for the sailors crossing the Pacific and sailing from one place to another. So predictability was very important for the early sailing ships. And indeed, if we look at the storm tracks here, we see they curve round this way in the southern hemisphere, and they curve round that way. So these are all the storm tracks that we've measured 1985 up to 2005. And there seems to be a little bit of absence in the middle there. Cyclones, hurricanes, there's another word, typhoon. They all basically mean the same thing. It just depends where it is in the ocean. Now, underneath, in 2013 was discovered in this area of the Pacific are very, very slow moving and very large waves. This is how high the wave is, 300 meters. If you don't think in meters, 300 yards. Sounds great to surf on, but it takes about an hour for the crest to actually fall over. And this is very important in subsurface mixing. It is deep. It's as much as 5 kilometers down, or about 3 miles deep. And this is something that was not known before, that we had these big waves through different layers of the ocean where the densities are different. This is what's happening in the Pacific. Rogue waves are also something that was very anecdotal until not so long ago. This is an idea of what a rogue wave might look like. These are some anecdotal reports of rogue waves. You can see how big they are. Just a couple of reports. Nothing clearly measured in those, but that's what was reported. But one rogue wave, the first rogue wave, was measured. Actually, it was in the Atlantic, and it's shown here on a water level gauge, a tidal gauge, and this was by an oil rig, and you can see that that was a 26-meter rogue wave that came out of nowhere. And this is what they do. They come out of nowhere. The conditions are just right, a constructive interference, and suddenly there's a rogue wave, and if you happen to be in the way, it's a little bit difficult because they can be big. The Ring of Fire. We'll come back to Ring of Fire in a minute, but this is a map showing you where all of the tsunamis have originated from 1850 up there to 2010. And the size of the dot there tells you somewhat the severity of it, where it originated. Interestingly, 71% of all the occurrences of tsunamis have been here where we are in the Pacific. Not to worry, if we're in deep sea, you won't even notice it. It'll just pass underneath the ship, and you won't even know there was a bump. It's only when you're on the shore that tsunamis are a problem. So, what about some features of the Pacific? As I said, we're in the Ring of Fire. This is the Ring of Fire around here. There's a lot of volcanoes in this area, which is also partly a cause for tsunamis. Tsunamis can also be caused by earthquakes, and they can also be caused by landslides, underwater landslides. Where you see these dark lines, we have what's known as subduction zones. This is where two tectonic plates, one's going over and one's going under. I'll come back to that when I talk about the Mariana Trench. Here's some more facts. So the salinity also varies. You can read that. As we move away from the equator, the salinity varies slightly. We have about 25,000 islands in the Pacific. The Pacific is closing very slowly because the continents are still moving. That's about 2 to 3 centimeters per year. And there's gold in them hills. Well, there isn't because there's no hills, but there's gold in the water. And as you can see, there's a nice lot of gold per person in the water. Problem is getting it out because the concentration is 10 to the minus 9. It's a nanogram. That's a really small amount. Tiny, 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 tiny. Couldn't see it. How would you get that out? It would probably cost you more money to get it out than the gold would be worth when you got it out. So don't bother. Lowest point on the Earth, here, the Mariana Trench. Where are we? Sort of around here. So we're not too far away from it. This is the point here, down there. So there's the data for it. You can see how long the trench is. I've given you the figures there. The average width, not very wide. And how does that trench get formed? We'll talk about that in just a second. Takeaway from this is this pressure. When you get down to the bottom of that trench, the pressure of the water pressing on you is immense. So where you're sitting right now, you're feeling 1 atmosphere pressure. It's an old unit. If you go down to the bottom of the trench, the pressure there is going to be 1,000 times what you're experiencing right now. So what happens to you if you're there? Splat. You'll be squashed. So this is what's happening in the Mariana Trench. There is a tectonic plate that's moving in this direction, and there is another tectonic plate here that's sitting on top. And as the plate is moving, in this diagram, it's moving from the right to the left. So the plate is moving, and this one is the stationary plate. It's pulling this one down. So it's making a big trench there. At some point, the force that's being held back can slip, and you can get an earthquake in these subduction zones. That's why you get so many earthquakes in the Ring of Fire around the Pacific, because of the friction releasing in these subduction zones. So that's the Mariana Trench. We visited it. You have to use something like this. So this is all flotation up here and sinking, and this is where somebody sits, very heavily armored, of course. It's got to withstand 1,000 atmospheres of pressure down there. You wouldn't want to be in there if it didn't withstand 1,000 atmospheres of pressure. We've only been down there twice with somebody in it. Well, those are the dates. And there's been 2 other descents. They've been remotely operated vehicles, ROVs, which for the other dates. And what do you see down there? You see things like this. This is a ghost shark. It goes back to 125 million years ago. And I often think when I look at this, this was the inspiration for Alien in the film Alien, or Aliens. Did you see that film? Where the jaw comes out, because it also happens on this animal here. It's a goblin shark, is what that's called. This is way down, 8.2 kilometers below the surface of the sea. Completely dark down there. So these fish have evolved different ways of getting food. Obviously, this is a light from the vehicle looking at it. As you go down, you'll find things like this. This is a football fish. This is a luminous lure that it can use to catch things with. There's where you find it. I'm not going to read those depths. You can read that. Here's a couple of other things we find in this area. This is the deep sea cucumber. It's absolutely gorgeous looking at it. And look how far down you'll find that. This is a carnivorous sponge, which eats meat, obviously. It's carnivorous. And you'll find that also very low down in the Pacific. Interesting paper that came out not so long ago showing that in this area, and actually in the subduction zones around the Ring of Fire, water is being sucked into the mantle. We are losing some water from the oceans, and it's going in. And in fact, this particular publication revised the estimates that what was being sucked into the Earth was about 4 times greater than what they'd originally estimated. These are the units here for this graph. It's not going down at a great amount, but there was obviously a lot of water down in the mantle that eventually comes back out. It comes back. Now, interesting, they found in some diamonds from deep down a form of water known as ice 7. Water, when it freezes, forms ice. That's ice 1. But there are many other allotropes of water when it freezes, and most of them are denser than water. So if they existed under normal temperature and pressure, they would sink, unlike ice as we know it being floated. This is another form of ice that's been found in diamonds, meaning it's been formed under great temperature and pressure, deep in the earth, for it to have that structure. This is the Mariana Trench. It is not the point closest to the center of the Earth. The point closest to the center of the Earth, surprisingly, is up in the Arctic. And the reason for that is because as the Earth is spinning, and this is exaggerated, it becomes somewhat oblate. It's an oblate spheroid. So the equator is wider, if you like, than the 2 poles, because as we spin, the mass spins out. So the closest point to the center of the Earth is up at the north. But This is showing you what things are like relative to the Mariana Trench. This is the depth of the Mariana Trench. This is the tallest building in the world. This is Denver. This is the Matterhorn. This is Everest. This is where commercial planes fly. That's where the Titanic lies. And this is the depth of the Mariana Trench. And everything fits in it with space to spare. So it's pretty deep. What about the next one? This is the second deepest place. This is Horizon Deep. Horizon Deep is in the Tonga area, and this is the data for it. And in fact, all these lines you see here, they're all trenches. So lots of deep. Where is Tonga? It's there. Let's look at it a little bit more closely. Just also in passing, has nothing to do with this film, by the way. Anybody see it? See this film? A few of you? I enjoyed it. It was good. Nothing to do with what we're talking about, though, but the name is similar, so you might get confused. Right, Horizon Deep, this is the area. Why is Horizon Deep of interest, apart from the fact it's deep below? It's because Apollo 13 came down in this area, and almost 4 kilos of plutonium was dumped in this area in the sea. So Apollo 13, you see Nixon here with the astronauts, Swigert, Hayes, and Lovell, on their safe return from outer space. So a little bit of plutonium floating around in the sea in Tonga Trench. For those of you who like trivia, this is a good trivia question. Where is the tallest mountain on the face of the planet from base, listen to what I say, to peak? And it is not Mount Everest. No, it is the one here in Hawaii. That one. It's Mauna Kea, and there's the data for it. Because most of Mauna Kea, of course, is underwater, so you don't think of it as being the tallest mountain. But if you go from base to peak, then yes, it is the tallest mountain. There are 7 natural wonders in the world. One of them is in the Pacific, and we'll talk about that one now. And that's the Great Barrier Reef, which is over here. Here's the Great Barrier Reef area. You can see it from outer space, in fact. These are the dimensions of it, the islands and the reefs, and it is the largest structure that is made from living organisms on our planet, including ourselves. These are some pictures from the reef when it was in better shape than it is now. Of course, it's having some problems. Here's a wonderful picture taken from the air around the Whitsunday Islands, in the Great Barrier Reef area. Just gorgeous. I do like that picture. How did it form? Well, it formed something like this. This was the original profile of the coastline. This is when the water was much lower than it is today. During the Ice Age, of course, a lot of that water was locked up in the glaciers, so water level was up to about 200 meters lower than it is today. As those glaciers and the ice caps melted somewhat, the water level rose to where we have it today. And this is where we end up. Some of that land is flooded. As you can see, it was sculpted in those days in the ice areas. And we have reefs growing on top of those submerged hillocks, for lack of a better word. Some of the data that's there. It's such a diverse place to go visit. Who's been there? Anybody been there? I mean, we've been there, so quite a few of you have been there. Did you go snorkeling there? Yeah? And I hope what you saw was better than what we saw, because we did it a year ago. Yeah, about a year ago we did. Didn't look like this. I'll show you what it looks like in a minute. Some diversity there in dolphins and whales and sea turtles. You also find dugongs down there, and of course humpback whales. You might have come across some of those when you were out there. So, how it was, 1980, 2015. This is a projection as to what it may look like in 2050, despite the fact that they are now trying to throw a lot of money at this and try and fix things up. Because we have coral bleaching going on due to climate change and also damage from some really bad weather down there. 2 years in a row they had some cyclones that caused damage there. So this is what it should look like, and this is what it looks like after bleaching. When we were there, unfortunately, most of what we saw was brown, There was very little color, and there was not a great diversity of fish when we were there, which was too bad. There is another problem, which I'll address in just a minute, that's moving down from the north on the Great Barrier Reef that the Australians are trying very hard to get rid of, and there is an active program to get rid of these things, and that is the crown of thorns, but we'll get to that in a minute. So this is the Great Garbage Patch in the Pacific Ocean. We've all heard of that, right? Have we? Yes? And do we think this is a real picture? I don't hear anything. Yes, I hear yeses. Do I hear any no's? I hear one no. The yeses have it. Well, it isn't. This is one of those fake pictures that comes up and tells you there's islands of plastic floating around in the Pacific that you can go walk on. Not true. It's true in places like this, because this is nasty pollution around an island. Now, this is not to say there's not a problem out there. There absolutely is a problem out there, but it doesn't look like that. So we have a couple of garbage patch areas. We have gyres where the water is going round and round and it's collected plastic in there. What does it look like if you go diving there? Well, you don't see plastic bags swirling around in a sort of big whirlpool thing. No, you don't. What's happened to the plastic is it has degraded into very small amounts, and the fish cannot distinguish these small amounts of plastic from food, so they are ingesting quite a lot of plastic. The opacity of the ocean hasn't changed a great deal, despite the fact there's a lot of plastic there, and it is indeed a problem because it's getting in to the food chain. And I think I've got to verify this, but I'm sure I read not so long ago that a whale was washed up and they investigated it and found 47 tons of plastic in the GI tract of that whale because it's a filter feeder. It ingests a lot of water, blows it out through the baleen and swallows what's caught in the baleen. So 47 tons of plastic. So these garbage patches here have high concentrations of microscopic plastic floating around in the water because it breaks down. So, not visible from space, you can't see it. This is a breakdown of the plastic in terms of amounts. This is 2014, 311 million tons. The estimate is by 2050, that's over 1,100 million tons that we will have disposed of in the oceans. And this is the ratio then of plastic to fish. And this is the ratio of plastic to fish in 2015 if we carry on the way we're going. And that's almost 1-to-1 at that point. So it's going to be a real problem. This is the plastic share of oil. It's 6% here. It's 20% there in 2015. And you can read that quote for yourself. What are we doing about it? That's how much by 2025 is the estimate. What are we doing about it? Well, anybody heard of this guy? Anybody? No? Nobody heard of this? A Dutch fellow who's come up with a brilliant idea to try and clean things up. And in fact, he's already done field trials with this. So this is the idea. He's going to deploy using, basically it's a net, a filter net that's going to be deployed, and it's going to use the natural currents of the sea to pass material through it. So you can see it here. It's just drifting along. So it will collect material, collect more material in the U-shape, and then finally, when they've got enough, after some months, the ship will come, pull it all together, and they'll pull the plastic out and put it on the ship and take it away. It's already gone through field trials. I'll get back to that in just a second, and hopefully this will work. This is the system again, looking at it. It's quite sophisticated, as you can see, satellite pods, navigation pods, camera pods, and lanterns on it in this arc here, and as you see, as it moves along, there's a fish, comes along, sees the net, and goes underneath it. So they're not expecting to catch any fish. They're only expecting to catch plastic, which I think is an absolutely great idea. This is without cleanup. This is estimated in 2030, and these units are in kilograms per square kilometer. And if this works the way he says it's going to work, they expect within 10 years to be able to pick up 90% of the plastic. And this is what it's going to look like with cleanup after this, after they've been through the area. Still a massive task because the Pacific is pretty wide. So here's the latest data. In fact, right up to January the 3rd, 2019, it was at this point in one of the garbage patches. They were testing it out in that area. They've had to take it back to Hilo, to harbour, to do some modifications and maintenance on it. So it's been through field trials here, as you can see, and it's moved all the way out to here where they were actually deploying it for a real test in the real area where there is a high concentration of plastic. Hopefully, whatever the problem was will be fixed and it will be redeployed and actually put into full use this year. We'll have to wait and see. Right, now let's have a look at some of the things that live in the Pacific. Of course, we've seen dolphins. Have we seen dolphins from the ship yet? Anybody? No? Yes? Gosh, you're not very responsive. No. Okay, well, if you do see them, they'll look like this. They're usually bottlenose, but there's more than one type of dolphin. There is, in fact, 39 oceanic species. Here's one of them, some of them, the ones you may see. There was one actually discovered as recently as 2011, and as soon as they discovered it, it went straight on the endangered list. Because that's what we're doing. We're getting rid of species. The prediction is by the end of the century, due to the 6 extinction that we're supposed to be responsible for, 75% of the Earth's species are expected to be gone by 2100. That's very depressing. Hopefully we can reverse that. There's also 5 river species of dolphins that live in fresh water. How smart are they? This is a human brain. This is a dolphin brain. It's bigger. This is the encephalization quotient. So we don't just measure brain size or brain mass to try and figure out whether an animal is smart or smarter than us. Well, so far we're leading the pack, but we're using some other terms to do it. So here's the human being, and next to it are the 2 dolphins, 2 types of dolphins. This is a bottlenose dolphin here. For those of you who are dog and cat lovers, dogs and cats are in this area here. So dolphins are measurably smarter than dogs and cats. And you will notice on this particular chart too that there's the orca, apex predator of the sea, and there's a shark too, also measurably smarter than dogs and cats. So dolphins, yes, they're supposed to be pretty smart. It would be nice if we could talk to them. What else is there? What's the largest fish? The largest fish is the whale shark. There's the data for it. It's big. The largest bony one, because of course this is cartilaginous, it has no bones. The largest bony one is the ocean sunfish. So there is a whale shark, and that is a sunfish. Let's look at some other pictures. This is the whale shark. It's a shark. It's not a whale. And that's how big it is. You see a diver there. This is a sunfish, an old picture. This was taken in 1910. And you can see people standing around this sunfish that was caught. There's the data for it. It was pretty big too. The crown of thorns. So coming back to the Great Barrier Reef, the crown of thorns is coming down from the north, and it eats coral. It's wiping out huge areas of the Great Barrier Reef. People are trying to eliminate it by basically injecting it with a salt solution to kill it. You don't want to pick these things up because the spines themselves are toxic. Venomous spines all over it, and that can kill you. So you don't want to pick it up. This is the lion's mane. It's the largest jellyfish in the Pacific. You'll find it around Australia and New Zealand. The stingers here, generally not fatal, but as you can see, it's pretty big, 2.3 meters in diameter. That's about my height. Well, actually, it's bigger than my height. I'm not 2.3 meters, I'm 1.8. So you can see the diameter of that. That's a big jellyfish. Then there's the urukanji, which is the opposite of being a big jellyfish. And this is a very small jellyfish. But why I'm telling you about this one is because it's dangerous. It can kill you, this thing. So there's a tiny little head up here with long tentacles that can be up to 1 meter long. And as you can see, the sting, very bad, 100 times worse than a cobra in toxicity. Can cause fatal brain hemorrhage and does kill people. This is another picture of it relative to a match head. As you can see, very difficult to see in the water. If you know they're in the water, you don't go in that part of the world. This is the blue ring octopus. Absolutely gorgeous to look at, and thank goodness it's more scared of you than you are of it. Well, hopefully you should be scared of it, because it's also extremely toxic. It contains tetrodotoxin, which is 1,200 times more deadly than cyanide, and I think you all think cyanide's pretty bad, and that's even worse. The good thing about them is they're very timid, and they will go away from you, so don't corner one, because that's when you're in trouble. They're not very big. And while we're on octopi, here's a big one. You'll find them in this area of the Pacific, and this area of the Pacific. Look kind of scary to me. They're pretty smart too. This is the colossal squid. Yes, there is even a bigger sort of octopus-type creature. This is the colossal squid. It has the largest eye of any animal in nature. There's the eye there. And this is actually a colossal squid attacking a bait squid, a very rare picture indeed, as you can see, taken in 2006. It's huge. You can go see one if you go to the Te Papa Museum in New Zealand. Anybody seen it? Few of us. Yeah, it's quite impressive. And that wasn't a big one, actually. Wasn't a big one. That's the size of it. It's a small specimen. These things, because they're so big, have 3 separate hearts in them to move the circulatory fluid around them. And you'll find them everywhere in this area. So not just the Pacific, but also in the southern sort of Indian Oceans as well. This is a giant clam, just out of interest to see what they look like. There's where it's breathing through. And you can see their size. They can get pretty big. They're hermaphrodites. That doesn't mean to say they breed with each other, but one clam can fertilize another clam, and they can choose the sexes that they want to be. They don't fertilize themselves, but they have no trouble fertilizing each other. So they have both organs. Now I just want to finish up rapidly with the Galapagos Islands. Who's been to the Galapagos Islands in the Pacific? Me too. We were there last Christmas, because if you haven't been, save up your bread and go, because it's absolutely amazing. And here's why it's absolutely amazing. Right, this is where it is. Here's South America. There's the Galapagos Islands on the Galapagos Plate. So it's a tectonically very active area. They've had 50-odd eruptions in the last 200 years, and it is this tectonics that gives rise to the islands. It's on a hotspot, and it's that hotspot that keeps creating islands in the Galapagos area. The islands are several million years old, and there's been a lot more of them. It's quite a wide hotspot here, and as that mantle comes up and protrudes through the ocean, it forms islands. And the really interesting thing about Galapagos is that you could see the age on the islands. They're all different. The flora and fauna are all different on these islands. And in fact, some of the islands are so new, there's almost nothing on them. It's just lava and some cactus. Fascinating. So here they are again with some ages on them. These are younger islands here. These are older islands over this part. Started about 15 million years ago, but some of them are lost now. They're underwater. The plume itself could be as much as 90 million years and has been forming islands over this entire period. And they've been moving slightly over with the tectonic plate, and as they get worn down, they get submerged, and they're gone. So the really old islands are all gone. These are relatively new in this respect. This is a quote from Darwin. Now, he only went to a few places when he was in the Galapagos, and he was only there for 5 weeks, despite the fact, of course, we have our theory of evolution stemming from his visit to the Galapagos Islands. And I think that's an amazing quote. This is one of the more elaborate, more beautiful craters in the Galapagos. So why is it so absolutely fascinating? It's because of this. Endemism. What is endemism? Endemism means that animal only occurs in that area. And in fact, the endemism is so interesting in the Galapagos, you will find island endemic species, meaning you can only find them on that island. You won't find them on any other island. Others that are just endemic to the Galapagos Islands, meaning you'll find them on different islands. And this is the breakdown. And this is the one to look at. These are the number of species of birds and fish and mammals and reptiles that are endemic to those islands. And because there's an 8 and a 6 there that are in red, they've gone extinct. So there were more. Absolutely fascinating. And then there's, as you see there's other things. There's just not enough room to put all the interesting facts about the endemism of the Galapagos on one slide. There are many different species in the plant world too that are endemic to the Galapagos Islands. These are Darwin's finches. They were collected. These are the actual ones that were collected by him in the 1830s on the HMS Beagle. He didn't actually collect all the species. There were more that he collected. And if you look at the finches known as Darwin's finches, they are species in development. They are diverging very slowly from each other, and depending which island you go to, you'll see different features on the different finches, the way the beaks have evolved for the feeding that they do. I took this picture. That's how close I was. In fact, it's so interesting on the Galapagos, you know, that when you go whale watching, you're not allowed to get closer than X meters or X feet to the whale. The whale can come close to you if it wants, and you can stay there and watch it. Here, you have to get out of the way. You're told to get out of the way. You have to keep a certain distance away from any of these animals, because they do not move. If you approach them, and they will approach you, and then you move. Here's another one that was there. And we see these all over the place. And sometimes it can be difficult to walk because they're just lying there. I'm not kidding. The flightless cormorant, unique to the Galapagos. This was just born. We were there hours after it had been born. You could still see the afterbirth on the stones, or the remains of it. Anybody want to guess who the diver is? Yeah, she's sitting in the front row. Turtles. And at one point, she was surrounded by turtles. You know when I said you had to move away from them? She couldn't move. Turtles all around when she went deep sea snorkeling. Yes, there are penguins on the equator. Trivia question. Are there any penguins in the northern hemisphere? The answer is yes, and this is why. They can be about 1.5 degrees above the equator, these penguins. They're the Galapagos penguins. They're endemic to the area. This is the blue-footed booby. See the blue feet? That's the blue-footed booby. This is a marine iguana, also endemic to these areas. So we have land iguanas and we have marine iguanas. And of course there is the great tortoises. The shells have different structures on each island. You can tell from the pattern which island they come from because they're unique. This is a land iguana, also endemic. This is a close-up of the land iguana as it charged me. I'm kidding. They don't do that. They move so slowly, at least when we're there. A couple of albatrosses, albatross chicks, who were trying to learn to fly when I took this picture. They did not get off the ground. Probably they're flying now because that was a few months ago. This is a Nazca booby chick that has just hatched. There's the mother, there's the chick, and this is a Nazca booby sitting on one of the eggs on one of the islands in the Galapagos. This is a finch, a yellow-breasted finch. This one is female. Males have red coloring on here. This is a very unusual gull. It is a nocturnal gull. It feeds at night. Although it's awake during the day, it only feeds at night. And we had them flying around our ship, feeding off whatever when we were churning up as we went from place to place. And that brings me to the end of the Pacific Ocean.